Algebra Review Lesson 1-1, 1-2, 1-3. In algebra we have variables that we use, and the variables are basically placeholders, and we could use other symbols and things, but the variables work best when they're letters, because some of the things that we actually are replacing for, like velocity, we can use the letter V. For time, you can use the letter T. So it just works best to use letters. They're really just placeholders. They're something unknown, and we can substitute values in for them, and we can evaluate. We can use the formula to solve. We can do a number of different things. I like to think of formulas as like recipes, and if you're following the recipe, you want to make sure that you're putting the right ingredients for the right parts of the recipe. For example, if you were making cookies and you accidentally put salt in for sugar, adding 2 cups of salt to a cookie recipe is going to result in disaster. So it's important that we actually follow what the recipe states. So one of our formulas that we would use is this simple interest formula. There's different forms of interest: compound interest. This is simple interest. And anytime we don't see the operation sign in between variables, we can assume that it's multiplication. The I stands for interest, and that's the amount that we will make off of our money in the account. The P stands for principal. And the principal, another way of saying that, is the start amount, the amount we start with. So if you put $100 into the account, the $100 would be considered your principal or starting amount. R stands for rate. Now the rate is a percent, but we must write that percentage as a decimal. And what we mean by that is, if you have 7%, that's going to equal 0.07. You always take whatever the decimal is, the decimal would be here on the end of this, and you move it 2 places to the left. Always 2 places to the left. I don't care how many numbers are in the percentage, it's always 2 places to the left. So 125%, 2 places to the left would be 1.25%. So that's the value that gets plugged in for the R, for the rate. Probably the number one mistake when people use the simple interest formula is they plug in the rate as the percentage. So if the rate says 5%, they stick a 5 there and they get it wrong. T stands for time, and it's typically in years. If you see something that says it's calculated annually, then you know you're dealing with years. But that doesn't mean that even if it's in years, you can't still deal with months. 6 months would be a half, so you could put 0.5 in for time. 3 months would be a quarter of a year, so you could put 0.25 in for time. You could put the fraction in as well. So whatever we have, we would substitute the values: the principal, the amount being plugged in, put into the account, the rate as a decimal, and how long it's put in there in terms of years. That will equal the interest that we're making off of it. Another formula we use is known as the D equals RT formula. Again, since there is no operation sign, we will assume that that's multiplication. The D stands for distance, how far we're traveling from one point to another. R, once again, this is rate, but it's not the same rate as up here. This is now speed. And T is in time. And time could be hours, could be days, could be minutes, seconds, whatever. You just have to make sure that whatever your answer is, that it possibly reflects the time unit you're using. Now this is the formula we use for distance if we know the rate and the time. We would multiply the two together and it would equal our distance. If I'm going 60 miles an hour down the freeway for 3 hours, I'm going to cover 180 miles. That's the distance I'll travel. Now we may not be looking for D. We might be looking for R. We might be looking for T, in which case we can use the same formula but in a different variation and allow us to solve for that. So here there's the same formula, except now we know the distance and the rate, and we're using it to calculate time. Here we have the same formula again, except now we're looking for the rate after given the distance and the time. It's 120 miles to Grandma's house. I have 3 hours to get there. So if I do 120 divided by 3, I end up with 40 miles an hour. I can go 40 miles an hour and still get there on time. So whichever formula I'm looking for. So if we actually use that, find the average speed, this is the question right here. That's what we don't know. And speed means rate. So since the rate is what we are looking for, if we go back to our choices, this would be the formula that we actually want, because that's the one that shows what we're looking for, the rate. So we know we're going to take the distance and divide by time on this problem here. Train traveling at 75 miles in 55 minutes. We know the rate equals the distance divided by the time, which means 75 miles needs to get divided by 55 minutes. Now, a lot of people make the mistake and they get an answer and they say automatically miles per hour. But in reality, this is going to be miles per minute, so we need to keep that in mind. If we actually take those two values and we divide them, we get 1.36 repeating. So we could say that's 1.36 with a bar miles per minute. Or, as a fraction, we could say 1 4/11 miles per minute. So not miles per hour, but miles per minute. All right, switching into exponents. Evaluate the following powers. Number one mistake made here. We have an exponent of 3, a power of 3, and a base of 5. Base is the large number. It's always written to the top right. This means 5 times 5 times 5. Commonly the mistake is 5 times 3. People think 15. Does not mean 15. 5 times 5 is 25. 25 times 5 is 125. Big difference between 125 and 15. So be very careful. The base. This number here, this 3, is telling you how many of them there are. There are 3 bases being multiplied together each time. So does it work to just switch them around? Is this still going to equal 125? No, because the base number is changing. We now have 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. This number here is representing those 5 3s. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So they are not the same answer. Switching them around does not work. There are a few exceptions to that. 2 to the 4th power is 16, and 4 to the 2nd power is also 16. That's just a coincidence. Most of the time, you cannot switch them around and get the same answer. Now, if we had this situation, this is more like our formula in a sense, where we have a value for the variable that we could substitute in, and we're now dealing with 4 to the 3rd power, which means 4 times 4 times 4. 4 times 4 is 16, 16 times 4 is 64. So that's evaluating, coming up with an actual answer. That's what evaluate means. Now, if you were to take this expression, it's possible that if you're not following what we call the order of operations, you could get a whole bunch of different answers. What typically happens on a problem like this, the mistake that's made, is someone goes 6 plus 3 is 9, times 2 is 18, minus 2 is 16, times 4 is 64, plus 3 is 67, and times 2 ends up with 134, which would be incorrect. All right? If you follow the order of operations, you should come up with 10. So here are the order of operations. First of all, you must do anything that has a grouping symbol. Parentheses, brackets, those are considered grouping symbols. But this is also a grouping symbol. Top from bottom. The line in between is a division sign grouping those two sides. So you would do everything on top, do everything on the bottom. The last thing you do is divide top from bottom. So we end up with those types of grouping symbols we would do first. The last problem we looked at, no grouping symbols, so we didn't have to worry about that step. Step number 2, evaluate any powers, any exponents. There were none in this problem. There's no exponents. So again, we would skip that step. The first 2 steps are skipped in this case. Now we come to where some problems exist occasionally. People think they have to do all multiplication first. You don't have to do all multiplication first. you have to do all multiplication and or division first. Start on the left-hand side of the problem and you work your way to the right, and if you come to a division sign, do those numbers. Do the one on the left and the right of that division sign. If it come to a multiplication sign, do those two numbers. Whatever it is as you work from left to right, take care of all your multiplication and division. In this problem, there's no division, but there is multiplication. There's multiplication here, here, and here. So we need to do those first. So the 6 plus, we haven't done anything with that. It stays. 3 times 2, that's 6. Minus 2 times 4, 8. Plus 3 times 2, 6. So I went ahead and I've done all of that. All the multiplication from left to right. There was no division. And the last step of order of operations, do any addition or subtraction from left to right. Commonly the mistake that's made on this one is people would do all the addition first. They'd go 6 plus 6 is 12, 8 plus 6 is 14, and then they would subtract those two and they'd end up with -2. We don't want that answer. We want to work from left to right. So I'm going to move these down a little bit. We would actually go from left to right. 6 plus 6 is 12. 12 minus 8 plus 6. 12 minus 8 is 4. 4 plus 6 equals 10. So we end up with the answer of 10. That's order of operations. First operation would be grouping symbols, powers, multiplication and division from the left side to the right, addition and subtraction from the left side to the right.